All right. Okay, I'm going to do 2 demos. One got me inspired to do an extra one. Cool, thank you. And the first one is going to be a continuation on this interface discussion. And I'm basically going just like to show how things are done, but from the JS side. Or at least how we have prepared the things to be done by multiple languages, but they're now mostly used by the JS side. And so, yeah, we peer-to-peer, there's a lot of things. We just came from a talk on interfaces and peer-to-peer interfaces. We discussed a lot how peer-to-peer is like this set of modules that plug very nicely with each other, that each module has a very specific, well-defined interface, so that we can just like swap them and put new pieces, upgrading our networking stack. I should show some images of like what these interfaces look like. But just to give you an idea, like for each of these pieces, like for each of like these building blocks that you are used to see on peer-to-peer, you get like one of these repos. And they always start with interface dash and then the type. And then on that repo, you get like modules that implement the interface. Like if you implement your own, you're welcome to submit a pull request and add to the list. You get really a nice badge so that people recognize on your repo that like you implement the interface. It's like a peer-to-peer compatible module. You get like some code to just set up tests. And this is like those kind of things that when you do JavaScript, you have to deal with because we don't have nice interfaces. And so the way that we overcome, nice way to describe interfaces for programs to implement. And so a way to overcome that is just like create a set of tests that people can import and use. And one of the very good examples here is the stream muxer. So the stream muxer was actually the original interface dash repo for peer-to-peer. There are currently 6 modules between Go and JS that implement this interface. They also get a nice badge. You get like some code to set up these tests on your own test runner. Go has a specific way to set up tests, and you can like find it how to do it on the Go repo. It's well described here. But when you scroll down, you kind of like have this description of like, we don't want to be like super explicit, and like sometimes this interface changes and then we have to update them. But like what we want to communicate is like what should be the things available to the user, like attach muxer to a connection. And in JS, we said, okay, it's muxer, you receive a connection, and you tell if it's a listener or a receiver. Go could be a completely different name, could be a completely different way to attach a muxer to a connection. That doesn't matter, but at least should expose something. And then all of the pieces that implement that interface in that language should exactly expose the same function. Same thing for dialing and listening. And so with this interface and this test suite that's here, we not only, sorry, like I wanted to check the source folder because this is the module that is a test suite. So the code of the module is the test, not the test of the module that is a, never mind. You have here a bunch of tests that test like basics, open the stream from the dialer, open the stream from the listener. It opens like a connection, just like attaches from both ends. Open a stream from both sides. Make sure that like we can open streams from both sides. There is some other tests like closing. Like if we closing the stream, like do we close the muxer? Because some muxers, when you close the streams that were open, like the muxer auto destroys. And we want it for peer-to-peer that like you can have the muxer open, close all the mux streams, and keep the muxer because you might still want for future things. You just don't have like any use for it right now. Then there's like stress tests, and this we call the mega stress test because like it takes an hour to run. It's like how we detect memory problems and so on. And so with this battery of tests, we implemented 2 stream multiplexers for JS. One based on Speedy, one based on a thing that we created in-house called Mplex. And we can just like run the tests on these modules and see that they are compliant to that interface, right? This is how we test for that interface in JS. We see it passes here. If I go to Mplex, to do the same thing. Like both of them are passing the same interface. So now I know, and this is just a browser test. Let me finish. Let that one finish. Okay, now I can run this again. It's using the same port. So now I know I can go into my libp2p bundle and just like replace one stream maxer by the other, and both will work on my stack. So yeah, that's how we get to play with multiple building blocks on libp2p land. Cool, this was one. You can find all the other interfaces for peer routing, for content routing, for peer discovery. You always get the nice badge, and yeah, that's it. Okay, that was the first part of the demo, or the first demo. The second one is really how to plug these things together. And I'm going pretty quickly. You will find all the code that I will run on the JS libp2p repo on the examples folder. You can find a bunch of examples of like how transports, protocol, and stream multiplexing works. You have the list here. So if we go to that code, I was already there. If we go to that code, and let's try with the transports first. Exactly. So most of these examples always have like a create node function, and this is just like creating a peer info and adding a multi-other to it. There's always a part where like the action happens, and here we are just like starting nodes and like creating a connection between both. But what I really want you to pay attention is this bundle, right? Like this constructor for the libp2p node. So here we can see that it's pretty simple. Like I think this is a laser pointer. Oh, nice. I got your tip. And so, yeah, the bundle here, it accepts the libp2p class, you get a constructor, and you have the defaults. So I, as a user of libp2p, I create my own libp2p node that extends the libp2p skeleton, and I say I want to use transport TCP. So this is pretty much like a libp2p stack that does the protocol multiplexing, but doesn't do any sec IO, doesn't do any peer discovery, just like TCP. So if I run this code, it basically will do the create two nodes, dial from one to each other, and print the values. Okay, there you go. So node 1 is listening, node 2 is listening, one dials to the other one on the dial protocol thing, and writes hello peer-to-peer world, and the message passes. So very simple, you got protocol multiplexing over TCP. But this is not very exciting. Like anyone could just like require the net module and do the thing, right? So let's go to the stream maxer example. Protocol and stream maxing. So here we have again like my defaults. The rest of the code is pretty much the same. It's dialing on protocols, and like again now I'm using TCP, and I'm saying that I have a stream maxer. I'm using Speedy for this one, and so when I do multiple dial protocols from node 1 to node 2. Instead of creating multiple raw sockets, I'm actually creating mux streams over that stream maxer. So I'm reusing the connection. And for the user, this is pretty much the user is pretty much transparent, right? Because you call still the same thing, and libp2p is smart enough to understand, oh, I have a stream maxer to this peer, I'm going to use it. If not, I try to open a new connection. And we are all happy. So if you run that now, stream maxing. So protocol A, protocol B, another con, and protocol B. So by the way, just in terms of API, you have dial protocol. You basically specify the peer that you want to dial, the protocol in which you want to talk with a peer. Here, I said like I want to talk on protocol A, could be any kind of string. Here, protocol B, and here is like, so when node dials to the node 2, it can open even multiple connections to the same protocol. So multiple listeners for the same protocol. The other example I have here for stream maxers is with, no, this is my editor. So, Okay, this one is pretty much the same, just like resends the addresses. I'm going to run this one so that you can see it works. So it did the thing. And in either of these examples, one thing I can do is instead of like using speedy, I can do here and change to multiplex. And just to make it obvious, I also rename these variables. Now I'm going to run. And it did the same thing. Like, again, like it was super swappable. Like the module implements the same interface. It works. Come on, this is very exciting. Like, but it doesn't stop here. It gets even more complex. So there is many other things. Discovery, so like detecting, using something like multicast DNS to find peers on the local area network. Same thing, like peers will find each other. Just for sake of time, peers will find each other through this peer discovery, and once they discover the peer, they just say, okay, I found a peer on this local area network. But also you can do things like peer routing. In peer routing, so in this example is more advanced one. We are already saying, I want to use TCP, and this could be multiple transports again. I'm saying I want to use Mplex. I'm saying that I want my encryption of my connection, con encryption, to be SecIO. And I want to use this DHT module, which gives the peer routing and content routing superpowers to my peer-to-peer bundle. Then I also have my config values, and this is like the standard config, like the JSON object, that like has some config options, and I do the same dance. I create nodes, and I use these properties to connect them. So here, like node 1 dials to node 2 dials to node 3, and then node 1 is going to use content routing to provide, and then like the content node 3 will find the providers of that node 1. Did I enter the folder peer routing or content routing? Well, never mind. It shows the trick anyway. They are both the same color, of course. Yeah, example 1 is peer routing. Example 2 is content routing. So just make sure I didn't lose you, because node 1 is going to say, hey, like if you're looking for something, come find me. And then node 3 is going to find the nodes that have that are providing that CID. Does it make sense to everyone? No, I didn't lose anyone? Yes. Cool. So again, creates the nodes, does the thing, and eventually we'll print the results. Oh no! This is the pool reader problem. We found this morning. There was like a module.
Yes, we're doing when we're not supposed to.
Yeah, okay. This was something that was broken this morning. I'm sorry. Like this example works. But yeah, like later this evening, you'll be able to find this example working 100%. And so, yeah, like you get all of these properties. As you saw, it's very easy to like configure with peer-to-peer. In the README, you get like an example of like all the things you can do. Again, you have the transports. You can pass the class types or even an instance. So if you have a transport with a little bit of setup, you can pass the instance of the transport. You can even like use multiple stream multiplexers at the same time. Why not? You might want to talk with different parts of the network that have to support both. You can also, but that's why this is always an array. Like you can support multiple encryption channels. You can support multiple peer discovery mechanisms. You can have multiple peer routing things. You have like all these configuration values. Some experimental flags. Yes, with peer-to-peer also exposes PubSub. And then if you want to learn like the interface of with peer-to-peer, we have like a bunch of things here from like starting a node and stopping a node. After all, like this is a network thing. It needs to start and stop. So we have like this new with peer-to-peer node start, and then we could do like a dial. And a dial, and dial protocol, the distinction is really like this warms up the connection. So I can dial to someone and like do the SecIO handshake, the stream mixer handshake, all those things. But I'm not going to create a MOOC stream to that node yet. I'm just going to warm it up. And then if I want to dial a specific protocol, me as a user of a peer-to-peer, like bitswap, for example, I say I want to dial bitswap to this peer. So it does the final protocol multiplexing to that peer. We have the close connection. We call it hang up because if you dial, you kind of like hang up. Some people have different opinions about the name of this. Then like you have peer routing with find peer, content routing, like the things I was showing you. You can handle multiple protocols. This is how you do it. Like you say the string for your protocol, the handler func, and the matching func. And the match func is if you want to do something more exotic, like semver, for example, for your protocol, you can use a matching function to do the semver, so that you can have protocols that handlers that support multiple versions. Same thing for handling, and then like we have this event listener. We have a friend flying. We have these event emitters that like when you discover a peer, when you connect to a peer, and when you disconnect from a peer. So if you want just like for statistic reasons, stats reasons, want just like listen to this, or if you want to do something more proactive, when you like discover a peer, connect to it, you can do it. By default, just IPFS, for example, as soon as you discover, you just connect to it, because why not? You can do the ping. You have access to the peer books, like all the peers you know, like the peer info, so like information about yourself, like the addresses that where you are listening, the addresses that other peers see you from the outside world. And you also get the PubSave API, which is the same API that just IPFS exposes. So if you are familiar with that one, you get this one as well. There's other things here. There's also a stats API. So you get kind of like data from how you are interacting with the nodes that are on your swarm, and many other things. I think this is it from showing how to configure libp peer-to-peer nodes. Any questions? Was it good? Johnny, do you have a mic?
So if you want to just cover what the peer protocol it supports, is that dial or is it dial peer? Like, is it warming up the connection? Basically, like if you warm up the connection, say what protocols is it?
So when
are available?
Oh, the protocols that are available. So when you dial to the peer, so like here, the only thing, this peer could be a peer info, which has the protocols that the peer supports, or that we know that the peer supports, or it's peer ID, or it's multi-other. Once we dial to them and we do the identify handshake, it's where the other peer tells the protocols that they support. So we can just go to this object, which is in our peer book, kind of like the yellow pages of peer-to-peer, and you can see which protocols that the other peer supports. But then again, it's identify, and identify only happens once when we first connect with each other. So imagine you have an application that can like handle protocols and handle multiple times. It doesn't mean that like that is up to date. So the best thing you have to do is really, well, you can use that as an heuristic to know if you should dial, but you can always try to dial on that protocol, and the other peer can tell you that it is or it isn't supported. Did I answer your question?
Yeah. So the protocol is string. So in your case, it was like
Yeah. So we in IPFS land, or even the internals of peer-to-peer, we do a lot of like slash the name of the protocol and then a version, so that we can upgrade in the future. Any more questions? All right. Thank you so much. Oh, we have a question here. Microphone. Please start here with the red dot.
Do you think that we should make a version of that's cross implementation?
Yeah, absolutely. Like you mean basically this description, right?
That like configuration, but some like configuration language could exist.
Yeah. And I believe you opened an issue just for this maybe some time ago. And yeah, I would love that because then it's obvious for every user like how to configure every single libp2p node independent of the language. We've seen yesterday how it is easy to add a transport to Go nowadays. That's awesome, but it would even be better if it's just like a description, the recipe, and then we tell it to we give it to the language, and the language gives us an instance of a libp2p that has all the things we need. At some point, we even had the idea that like to have a website that looks like an ice cream machine, and like you can like say, oh, I want some more TCP and some more stream muxer and some more sec.io, and like it just mixes all up, and like instead of like putting like a Sunday out, it puts like a JavaScript bundle of the configuration of libp2p you wanted. I don't know, that was just like a funny idea. It's good. All right, more questions?
Yeah, I guess it would be pretty useful for tests. So you could very easily use these configurations and then run them across the same test over and over.
Yes. Yeah. And so I guess the question is like, how complex does that language need to be? Like, if we have identifiers for each of the protocol implementations, if we have just like a multi-codec like for the multiple peer routing, the multiple transports, etc., then we just need to have this, but with those IDs, so that both Go, both JS, Rust, and all the others can just see those IDs compared to the table, grab the modules from the shelf, and mix the ingredients and make the bundle, right? So yeah, like I think we can very quickly start with that. And like leave the configuration to be something external, like the configuration of each module to be something external. It becomes more complex if you want to say in that language, oh, I want to use PD, but in a special way, right? That's where it gets a little bit more complex to do that multiple language. All right, I don't know, like I'm trying to avoid like having a huge backshed. I think we can do something very quickly that serves a lot of purposes. But we can have the backshed. Yeah, and so I don't know, just curiosity. For example, we have this peer routing and content routing, and we like to get these. We get it through the DHT, and if you go to the DHT, you'll see it has like all of these badges because it really does all of these things at the same time, right? It has peer routing, it finds other peers. It has content routing because like we get to know where the content is. And also there's peer discovery because when you random walk a DHT, you are discovering random peers and like refreshing your routing tables, which is super useful. But ideally, this is not bad, but like ideally, all of these pieces that are here inside this one package should be also separated so that when you are loading it into libp2p, you can say, I want to just load this peer routing module and these two other content routing. Right now, we do that by enabling, disabling parts of it. Like you get the whole package, and then you can disable a little bit of it if you want to. Although probably most of people that will use the DHT want to use the whole thing anyway. Time will tell. Cool. Any more questions? All right. I think this is it then. Thank you. Cool.